How does the Joule define heat energy? Imagine you are pushing a swing back and forth. The energy you use to push is transferred into the swing, making it move. This is similar to how heat energy works in science. The scientist James Prescott Joule studied how energy moves and changes form. He discovered that heat is a type of energy transfer, not just something stored inside. When energy moves from one place to another because of a temperature difference, that is heat. Joule showed that heat can be measured in units called joules, named after him. He did experiments with water and gases. For example, when he stirred water or compressed a gas, he found that mechanical work, like pushing or stirring, could turn into heat. He calculated how much work was needed to produce a certain amount of heat. For instance, about 4.186 joules of work could raise the temperature of 1 gram of water by 1 degree Celsius. This linked heat directly to mechanical energy, which is energy of motion or position. In thermodynamics, heat is defined as energy transferred between systems or their surroundings because of a temperature difference. It is not energy stored inside a system but energy moving in or out. Joule's work helped establish the first law of thermodynamics. This law says that the change in a system's internal energy equals the heat added plus the work done on it. So, heat is one way energy enters or leaves a system, and it can be turned into other forms like mechanical energy. This idea explains how engines work. They convert heat energy into motion or use mechanical work to produce heat. For example, in a power plant, fuel combustion creates heat. That heat is then transformed into electricity or mechanical energy. Joule's experiments also show how electrical energy passing through a conductor produces heat, which is called Joule heating. In simple terms, Joule defined heat energy as a measurable amount of energy transfer that is equal to mechanical work. This means heat is a form of energy that can be measured, converted, and understood within the rules of thermodynamics. His work made it easier for scientists and engineers to see how energy moves and changes in real-world devices and processes.